Hello everyone, welcome back to Study Gap. Today we are going to start with a very important topic in digital electronics, Boolean algebra laws. So Boolean algebra forms the foundation of digital circuits and logic design. Just like we have algebraic laws in mathematics, Boolean algebra also has its own set of laws. These laws help us simplify complex logic expressions into simpler ones. So let's take a quick look at the basic Boolean laws. First, idempotent theorem, which is x plus x equals to x. Second one is x dot x equals to x. Second one is boundness theorem, which stated that x plus 1 equals to 1 and x dot 0 equals to 0. Third one is equality theorem, which is if x plus y equals to x plus z and x dot y equals to x dot z, then y equals to z. Similarly, complement theorem. So if x plus y equals to 1 and x dot y equals to 0, then x equals to y complement and y equals to x complement. Next one is involution theorem. It is x double complement equals to x, or you can say y double complement equals to y. Adsorption theorem. X plus x dot y equals to x, or x dot x plus y equals to x. Next, consensus theorem, which is x dot y plus x bar dot z plus y dot z equals to x dot y plus x bar dot z. Second one is x plus y whole into x bar plus z whole into y plus z equals to x plus y whole into x bar plus z. Next, number 7, adjacency theorem, which is x dot y plus x dot y bar equals to x. And number 2, x plus y whole into x plus y complement equals to x. Number 8, associative theorem, which is x dot y dot z equals to, you can write like this, x dot under bracket y dot z, or x plus y bracket close plus z equals to x plus bracket start y plus z. Next, come to the last one, which is DeMorgan theorem, and this is very important in Boolean algebra. Number 1 is x plus y complement equals to x complement dot y complement, and number 2, x dot y complement equals to x complement plus y complement. So in upcoming videos, we will see how to apply these laws to simplify logic circuits step by step. So stay tuned to the study gap for easy explanation and examples.